right, let's look at our Math 191 Pre-Calculus exam review, starting with number 1. So for number 1, they told us that cosine was equal to 3/7. Now, on your formula sheet, you can see cosine is equal to x over r, so we know that x is 3 and r is 7. And then if we use Pythagorean theorem, x squared plus y squared equals r squared, put 3 in for x and 7 in for r, and then we can subtract the 9 from 49 to get y squared is 40. Take the square root of both sides, and we'll get the square root of 40. 40 is 4 times 10, so square root of 4 is 2, so we get 2 square roots of 10. So now I can come over here and say, okay, I knew x was 3, and I knew y was 2 square roots of 10. When we give our answer, we're never going to leave a radical in the denominator, so I'm going to multiply top and bottom by the square root of 10, and that gives me 3 square roots of 10 over 2 times square root of 10 times square root of 10 would just be 10, and so 2 times 10 would give me 20. For number 2, it said find the exact value of sine 30. All right, so I'm just going to come over here to my circle. Here's 30 degrees, and remember that the x value is the cosine and the y value is the sine on the unit circle, so that's where we're getting the 1/2. For number 3, they asked me to find the cosecant of 90 minus x. Now remember, 90 and pi over 2 are the same thing. So if you look on your formula sheet on your cofunction identities, cosecant pi over 2 minus x is equal to secant x. For number 4, it says find the exact value of the cosine of negative 3 pi over 4. Negative 3 pi over 4 is not on my circle. So remember, when you don't like the name, you can change it. So I'm going to find the coterminal. So I'm going to take the angle they gave me and either add or subtract 2 pi to find a coterminal. Since this one was negative, it was too small, I'm going to add 2 pi. So that's 2 pi over 1. I need a common denominator to add my fractions. So I'm going to rewrite 2 pi over 1 with a denominator of 4. So if I multiply the bottom by 4, I multiply the top by 4, that'd give me 8 pi over 4. So negative 3 pi and positive 8 pi is going to be 5 pi over 4. That would be our coterminal. So finding the cosine of negative 3 pi over 4 is the exact same thing as finding the cosine of 5 pi over 4. So come over here to your circle. Here's 5 pi over 4. And again, the cosine is the x value. So that's where we're getting our negative square root of 2 over 2. For number 5, they ask us for the cotangent of 0. So again, if you look on your formula sheet, cotangent is cosine over sine. So that's the cosine of 0 over the sine at 0. So if we come over here, you can see that the cosine is 1 and the sine is 0. So cosine is 1, sine is 0. 1 divided by 0 is undefined. Division by 0 is always undefined. All right, let's look at number 6. So 6 says use trig identities to see which of the following is equal to 1 plus cosine times 1 minus cosine. So let's FOIL that out. So 1 times 1 would be 1. 1 times a negative cosine is negative cosine. Cosine times 1 is positive cosine. Positive times negative is negative. Cosine times cosine is cosine squared. So the positive cosine and negative cosine dropped each other out. That left me with 1 minus cosine squared. So when I have a 1 and a trig function squared, that's almost always a Pythagorean identity. So if you look on your formula sheet at your Pythagorean identities, you have sine squared plus cosine squared is equal to 1. If we subtract cosine squared from both sides, then we're going to get sine squared is equal to 1 minus cosine squared. So 1 minus cosine squared is just equal to sine squared. 7 says a 10-meter line is used to tether a helium-filled balloon. All right, so here's our 10-meter line. We're tethering it to the ground right here. Our balloon's going to be up here. And it says, because of a breeze, the line makes an angle of approximately 30 degrees with the ground. So here's my line, here's my ground, so that angle in between them is going to be 30 degrees. And what's the height of the balloon? Height is always a straight up and down vertical distance, so that means we're looking for this guy. So I know this angle, I'm looking for what's opposite, and I know the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So we're going to say the sine of 30 is equal to opposite h over hypotenuse 10. So sine 30 equals h over 10. To get h by itself, multiply both sides by 10, and I'll have h is equal to 10 times the sine of 30. Now you could throw this in your calculator in degree mode, or you can just come over to your circle and see that the sine of 30 is 1/2. And so that would just be 10 times the sine of 30. 10 times 1/2 would give us 5. Then for 8, it says let 3, -4 be a point on the terminal side of an angle. Find the cosecant. Okay, so x is 3, y is -4. So just as we did in the first problem, we're going to use Pythagorean theorem to find the missing piece. So we can say 3 squared plus -4 squared is equal to r squared. 3 squared is 9. -4 squared, the negative gets squared as well, so that's a positive 16. And so we're going to get 25 is equal to r squared. Take the square root of both sides, and I'd get plus or minus 5. Now, a radius or a hypotenuse is always positive, so that means that r is going to be 5. You might have also recognized the 3, 4, 5 triangle and just not had to do the Pythagorean theorem at all. So, by definition on the top of your formula sheet, cosecant is r over y. We just found r was 5, and we know y is -4, so we get -5/4. If you just wanted to verify your sign, because a lot of times on those problems, there'll be a positive 5/4 and a -5/4 as answer choices. So if you just want to double check it, remember that 3, -4 is in the 4th quadrant, and so all students take calculus. We know that only cosine and its reciprocal secant would be positive, everything else would be negative. So that means that sine and its reciprocal cosecant would be negative, so that verifies this should be a -5/4. All right, for number 9, very similar, cotangent is equal to -5/3, and they want us to find secant. So on your formula sheet, you can see cotangent is x over y, and secant is r over x. So that means that x is going to be 5 and y is going to be 3. One of those is going to be positive and one of those is going to be negative. And what determines that is the quadrant. So you'll notice for number 9, they also told me that not only is cotangent negative, but they also told me sine is less than 0. That means sine is negative. So I'm looking for where cotangent and sine would both be negative. Cotangent is the same thing as tangent, so tangent and sine are both negative in the 4th quadrant. Only cosine is positive there. So if I'm in the 4th quadrant, then I know in the 4th quadrant x is positive and y is negative, and so that's how I can tell on the -5/3 which one of those gets the negative. All right, so then I'm going to do Pythagorean theorem. Again, the negative gets squared with the y, so -3 squared would be 9. And so I'm going to end up with 34 is equal to r squared. Take the square root of that, and I would get plus or minus the square root of 34, but the radius is always positive. Please be careful that you don't accidentally say that r is equal to 4. I know that this is a 3 and a 5, but this is not a 3, 4, 5 triangle because the radius has to be the longest side. The radius would have to be the 5. So now I can say secant is r over x, so r was square root of 34 and x was 5. And again, if you just wanted to double check your sign to make sure that you hadn't dropped anything, we've already determined this is in the 4th quadrant, and so when you're trying to find your secant value in the 4th quadrant, secant is the same thing as cosine, and cosine is positive there, so secant should be as well, and it is. Then number 10, we wanted to know where tangent is positive and cosine is negative. So the only place tangent is positive and cosine is negative is in the 3rd quadrant. Tangent is also positive in the 1st, but cosine is positive there as well, so has to be 3rd quadrant. All right, then 11, they wanted us to find the cotangent of pi. So again, our definition of cotangent on the formula sheet is cosine over sine. So we're looking for the cosine of pi over the sine of pi. So come over here to pi. This is my cosine -1. This is my sine 0. So cosine -1, sine 0. -1 divided by 0 is undefined. Then for number 12, they ask us to find the reference angle. Now, reference angle is just your distance away from the x-axis. So if I'm in the 1st quadrant, it's just going to be whatever my angle is. If I'm in the 2nd quadrant, it's going to be 180 minus my angle, or pi minus my angle. If I'm in the 3rd quadrant, it's going to be my angle minus pi, or 180, my angle minus 180. And if I'm in the 4th quadrant, it's going to be 2 pi minus my angle, or 360 minus my angle, either one. How do I know what quadrant I'm in? Well, this is 0. This is pi, 3.14 divided by 2, so that's 1.57. This is pi, 3.14. This is 3 pi over 2, so 3 times 3.14 divided by 2 is 4.71. And this is 2 times 3.14, so 6.28. So my angle was 4.6, And so 4.6 is in here between 3.14 and 4.71. So that means that I'm going to take my angle 4.6 and subtract pi 3.14. So my angle 4.6 minus 3.14 gives me my reference angle of 1.46. All right, then 13, they asked me to find the exact value of tan 315. So I'm just going to come to my circle again. Here's 315. My tangent value comes from taking my sine and dividing it by my cosine. So these are my tangent values out here. So that tangent would just be -1. All right, then for 14, we want the exact value of sine 2 pi over 3. So again, I'm just going to come to my unit circle. Here's 2 pi over 3. And so my sine is the same thing as my y value. So that'd be positive square root of 3 over 2. For 15, it says to tell where cosine is equal to square root of 3 over 2. So we're doing the opposite now. They're giving me the answer and we're looking for the question. So I'm looking for the two places on the unit circle where cosine is equal to a positive square root of 3 over 2. All right, so cosine's positive in the first quadrant and the fourth quadrant. So I can see there's 1 right there. Cosine is square root of 3 over 2 at 30 or pi over 6. And here's the other one at 330 or 11 pi over 6. So for this one, they were asking us for degrees. If they had asked us for radians, we could have given that as well. All right, then for number 16, they asked me, what is the period for sine 1/2 x? So remember, the number in between sine and x is our b value, and we find our new period by taking the original period and dividing it by the b value. Now here are all your original periods over here. Sine, cosecant, cosine, and secant are all 2 pi, tangent and cotangent are 1 pi. So since this was sine, my original period is 2 pi, and that b value was 1/2. So if I say 2 pi divided by 1/2, I'm going to change, flip, and that's going to give me 4 pi for my period. 17, 18, and 19 all use this same equation right here. So we've got -3 plus 4 cosine 2x minus 1. So the first thing I'm going to do is I'm going to add this 3 over to the other side, just so it's easy for us to see what's being subtracted from y, because any value subtracted from y is my vertical shift. So what's being subtracted from y is a -3. Remember, you could think of this as the opposite of. So the opposite of positive 3 is -3. That's my vertical shift. And then this number out in front is my amplitude. So I've got an amplitude of 4. And then we can see that our b value is 2. So to find our new period, we're going to take our original period, which for cosine is 2 pi, and divide it by that b value, and we would get 1 pi. So the thing they asked me in 17 was, what's the amplitude? That was 4. In 18, what was the period? That was pi. And in 19, what was the vertical shift? And that was -3. All right, then for 20, it says find the value of arc cosine negative square root of 3 over 2. All right, when you see arc sine or arc cosine or arc tangent, they might also be written this way. Those are our inverse trig functions. And inverse sine is only valid in 1 and 4. Inverse cosine is only valid in 1 and 2. And inverse tangent's only valid in 1 and 4. So when we see arc cosine of negative square root of 3 over 2, we should automatically from that know that we're playing Jeopardy. That means that this is the answer, and we're trying to find the question, and we only have first and second quadrants to choose from. We get all of that from the definition of inverse cosine. Now, because this was negative, we have to be in the second quadrant because cosine's positive in the first and negative in the second. So I'm going to look on the unit circle in the second quadrant to see where my cosine value is negative square root of 3 over 2. And there it is right there at 5 pi over 6. All right, 21, arctan of square root of 3 over 3 means we're playing Jeopardy, that this is my answer. I'm trying to find my question, and I only have first and fourth quadrants to choose from. And so because this is positive, I have to be in the first quadrant. If it had been negative, I would have been in the fourth. So I'm going to look in the first quadrant and see where tangent is equal to square root of 3 over 3, and that's right there at pi over 6. Then arcsine of the sine of 2 pi over 3. These are inverses, but the only time you can cancel them is when this value is in the designated region. 2 pi over 3 is in the second quadrant. Designated region for arcsine is 1 and 4. It doesn't exist in the second quadrant, so I cannot cancel. So instead I'm just going to see what's the sine of 2 pi over 3. So the sine at 2 pi over 3 from the unit circle is square root of 3 over 2. So now I have arc sine of square root of 3 over 2. So same thing we were doing before. That means sine equals square root of 3 over 2, and I only have first and second to choose from. Since this is positive, I'm in the first